Hi, my name is Judith Fedelia. My number metric is 75223, and today I would like to explain a application of thermodynamics in refrigerator. So, let's go. There are three laws of thermodynamics, which is zero law of thermodynamics, first law of thermodynamics, and second law of thermodynamics. The zero law of thermodynamics is if two bodies are in thermal equilibrium with a third body. The third body are also in thermal equilibrium as well. The first law of thermodynamics is an expression of the conversation energy principle, and the second law of thermodynamics said that heat asserts that energy has quality as well as quantity, and actual process occur in the direction of decreasing quality of energy. So the refrigeration cycle is entirely based on thermodynamics, from the removal of heat from one body and transferring heat to the another body. Heat always flows from the body with high temperature to the body that has lower temperature. The transfer of heat can occur to three different phases, which is conduction, convection, and radiation. Conduction is the transfer of energy from more energetic particle to the less energetic particle, while the radiation is the transfer of energy due to the electromagnetic wave. And lastly, the convection, which is the transfer of energy between a solid surface and with an adjacent fluid, and involve the combination effects of conduction. So basically, it's occur mainly in the fluids. That's why our refrigerator consists of refrigerant fluids. Heat exchange that happen on the evaporator and condenser. These are the example of convection. So there are three components that are important in the refrigerator for the concept of thermodynamics applied in this area. So the important components in the refrigerator consists of three components, which are transport medium, for example, refrigerant fluid or fuel gas, compressor or decompressor. So these components are important because it will transfer the heat from one room to another room. All of this gas will pump through this compressor, and it will heat up the S curve, and the hot gas will travel along the S curve and will cool down over time, while the gas flow through this compressor will pass through this compressor, and it will cool down, and the cool gas will travel along the S curve and slowly warm up over time. So I built a diagram of a refrigeration unit. As you can see, refrigeration unit consists of cold reservoir, heat pump, and hot reservoir. Okay. The heat will pump from cold reservoir to the hot reservoir via the heat pump. But the second law of thermodynamics said this is process does not happen simultaneously. So we need work to put certain amount of work that will go certainly, and at the same time the work will also produce a heat. Okay, so also that means the amount of heat at hot reservoir is not same to the amount of it that produced on cold reservoir. So maybe it's double or triple to the amount of cold reservoir. So we can see that the heat is going to the hot reservoir, and we know that the heat on hot reservoir is larger than cold reservoir. And also heat that produce heat pump also produce it. So that's why the hot reservoir contains more heat more than cold reservoir. In conclusion, I already explained the concept of thermodynamics in refrigerator. So the second law of thermodynamics play the most important role in making our life become more easier and faster. The concept of heat transfer used in wide range in devices and in industrial processes. For example, heat exchanger, evaporator, condenser, radiator, cooler, and heaters. These are things that we can find out in a supermarket or at our house. Thermodynamics provide a framework in which the universe operates. So so I will end my speech here. So thank you for listening my explanation of thermodynamics in refrigerator. So have a nice day. Goodbye.